It's the inverses of the inverses is what I'm going to call it. So, yeah.
No, we only do that for graphing.
So, if we remember, what?
I don't get rabbits on the bottom.
No. This is just a refresher. So, this is the whole sine function, right? And this is the whole cosine. But what's in red is our only thing that's valid. Why? Because in order for it to be a valid one-to-one function, it has to pass the vertical line test, and it has to pass the horizontal line test. So that's why we ended up with what we ended up with. So looking up here at our sister functions, what do we think the ranges are going to be? Turn and talk to a buddy.
Man, what we doing?
Like for the quadrants? Yeah.
The quadrants, or like between negative pi to pi, like, you know what I mean? Like, what do you think we're going to end up with?
It'll be 1 and 3. That's all of them. Then I guess maybe that one's one. Maybe secant is one. And cotangent is probably all both, right? I don't know if that's allowed.
Okay. Cosecant is the sister to who?
Cosine.
Sine. Sine of x is in what two quadrants?
1 and 4.
1 and 4. Which would be between here and here. It is what we have in this little section. Is that 1-to-1? Is that a function? Does it pass the horizontal? What? Yeah, because it's between negative pi halves and pi halves. Is what I just drew my lines at. Does that pass the horizontal and the vertical line test?
Yeah.
It sure does. So, crazy news, the sisters are going to have the same, except for tangent. But we'll get there.
Why did you color over the whole graph?
Because I was trying to show that, like, it passes the,
Yeah. Sorry.
You're
I
good.
was a little bit confused.
So, where is secant secant is a sister to, which is valid in what two quadrants? 1 and 2. So if I were to draw where cosine is valid, I end up with this. Does that look valid to you?
Yes.
Yes. In between these two little lines, this is my new cotangent is the sister to tangent. Tangent is in quadrants 1 and 4, right? However, if I were to draw in between 1 and 4, this is what I end up with. It doesn't look like a big problem, but we do have a spot here and a spot there that are the same. So these will not be the same. Cotangent is going to be here. So 0 to pi is what two quadrants? 1 and 2. So cotangent is 1 and 2, secant is 1 and 2, cosecant is 1 and 4. But now we have our, we are going to have we're going to have individual slides for each of them. So the inverse notation here, what did we decide was basically two equivalent things?
The cosine, well, sine and secant are sisters.
Yes, but in terms of the inverse notation, we can write it two different ways and they both mean the same thing. What are they?
Sine or arcsine?
Arc. So you can write arc secant of x and then secant with a little -1. We decided that secant is a sister to cosine, and though they have the same quadrants that they're valid in. That new range is 0 to pi. Quads 1 and 2. Mm-hmm. I need a thumbs up when everyone's ready. I see about half the room with thumbs up. Okay, I'm moving on. So, crazy enough, this is practically the same thing. We have an arc secant of x. We have a secant -1 of x. It is -pi over 2 to pi over 2. So we're in what two quadrants?
1 and 4. Whoa, yeah.
1 and 4.
So the inverse notation is always secant.
Or is
Yeah, you can write it both of these two ways. This is valid and that's valid. It could show up.
wait, secant or cosecant?
Cosecant. Cosecant. Now I understand your question.
The arcs still don't have the -1s, right?
No. Jaden, I understand your question. I'm sorry.
So you first week.
But the range is gonna be the same as the sister function, right?
For cosecant and secant, yes.
But it'll be different for cosecant.
It'll be different for tangent and cotangent.
Cause it's, for tangent, it's x over y, and then for cotangent, it's y over x, right?
Thumbs up when we're ready to move on. Okay. So lastly, we have cotangent, which arc cotangent of x or in our new range we decided is different from its sister. So we have 0 to pi. Good. Which is between what two quadrants? 1 and 2. Okay, thumbs up when we're ready to move on. Is everyone ready? Okay. So, this is a lot. I know it is. But you will never, ever, ever, ever touch anything over here in quadrant 3. Number 1, you will always have everything. What are our 3 functions that are valid in quadrant 4?
Sine. And cosine.
So then what 3 are we missing that are going to be valid in quad 4?
Cotangent. Cosine.
And cosecant. So as long as you know, yes, oh my gosh, sorry. Miss K is having herself a day.
It's okay.
Okay, so as long as you can differentiate what quadrants you're in, you guys will be pretty solid, I would say.
Wait, can you go back to that?
Yeah.
So there's no quadrant, 3?
No quad 3.
Do not touch quad 3
That answer.
with a 39.5 foot pole. Don't do it.
So wait, why is quad 2 sisters and quad 4 brothers? Quad 2 is a sister, so it's a cosine, quad 2 is sisters. And why is quad 4 regular? So why isn't so for example, why doesn't quad 2 have cosecant as oh, okay.
These 2 are both down here. Just so happens that tangent and cotangent are in opposite ones, but the sisters are together otherwise.
I have a question.
Yeah.
So for the graph for the cotangent, where does it pass the does it pass the vertical line and horizontal line test? Yes.
It does.
Okay.
You see how it's one of those iterations of the... Okay. All right. So whenever I do examples for these, I like to break it down for myself. So cosecant is, first of all, 1 over y, right? Right. So it's a negative number, though, on the inside, which tells me between my 2 quadrants, first of all, cosecant's in what 2 quadrants?
1 and 4.
1 and 4. So between those 2, which of those quadrants am I in if I have a negative number?
4.
Q4. We know we're in Q4. Disregarding the, we're going to disregard that for a second, but if I have a fraction and that fraction equals 1, what do we know about the fraction?
Wait, what?
The top and bottom.
The top and bottom, the numerator and the denominator must be equal. So 1 must equal y. So where on our graph does y equal 1?
Pi over 2.
Pi over 2. You guys should write this down for yourself. A bank of possible function values. Yeah. This was negative pi halves.
Oh.
Remember, because we decided it was in Q4. That was my bad.
Wait, so the things that you wrote up in the right hand corner, yesterday when we wrote the tangents for those things, those are the cosecants?
Well, so this is, if you look on your unit circle, right? Look at your unit circle. Possible coordinate values are always 0, 1, 1/2, root 2 over 2, or root 3 over 2. And it's just a bunch of iterations of that, positive and negative, all the way around the circle. So when you look at something like 2 root 3 over 3, which of these values do you think that came from? Root 3 over 2. We know that because there's a 3 in there, so there has to be some 3 in our answer. So when we go down here, we're going to compare to sine being root 3 over 2. And then it's much like our first day doing these problems. So where on our graph is sine equal to root 3 over 2? I heard 1.
Pi over 3.
Pi thirds. Yeah. Because this we would have to do some work to get to. On our unit circle, we don't have any values that look exactly like that, right? So we're comparing it to the values that we do have, which are these up here. So of these values, how could you possibly get to root 3 over 3? Yeah, Josiah.
And our answer is always going to be equal.
Yes.
What I did is I just looked at the root 3.
Mm-hmm.
Saw the root 3, and it's like none of the other ones have a root 3 in the numerator.
Correct. So those were both sine values. Now we're moving on to secant, which we compare to our cosines, right? Because it's 1 over x. We do have a negative value, though. So what quadrant are we in if secant is negative?
2.
Q2. Which of our values is going to give us a negative 2 root 3 over 3?
Root 3 over 2.
So we're comparing it to when cosine is negative root 3 over 2, which is at 5 pi over 6. If you get a 2 out, whoa, what do we think of these values up here we originally had? We originally probably had a 1/2, but it would have been a negative 1/2. So we're looking for a negative 1/2. So where on our unit circle is cosine negative 1/2?
And 2 pi over 3.
Now, the cotangents are going to be exactly flipped from our tangents, right? because our x's and our y's are flipped. So yesterday, though, we decided that to get to a root 3 over 3, we originally came from a 1 over root 3, which would have originally been a 1/2 over root 3/2, right? That's how we got there. But now, this time, it's an x over y. We also have a negative number. Cotangent belongs in what two quadrants? 1 and 2. Which between 1 and 2 is going to give us a negative number?
Two.
Number 2.
Oh,
So that would be, we're looking for a negative cosine value. So we're looking for a negative 1/2 and a y value of root 3 over 2, which gets us what value? Now our cotangent, again, x and y are equaling 1. What do we know about x and y? X must equal y. So this pi over 4. Yeah.
It's starting to make more sense.
You still must love it? You still must love it? They just said that like.
Yeah.
How did we get from that for the negative root 3 over 3?
It's just like a lot of following.
Yeah, the negative one. Oh, cause it's a negative sign.
It don't sound bad at all.
Like, how did I get from here to here? Because I know that's my only option.
Cause there's
Like,
0, 1,
The work that we did yesterday to show what the different functions of tan could possibly be, it was like root 3 over 3, 1 and 0. But obviously today, now, cotangent here is going to be root 3. Cotangent here is going to be root 3 over 3 because these values are flipped, right? So it was just like the work I did to get back here. So I used, this is my only options from up here. And then when you cancel out the 2's, you get a 1 over root 3. And then you have to rationalize your denominator. But we only see where we started.
Cause
So,
were you just saying that the reason why we used 1/2 was because of the 0, 1?
so tomorrow we get to do some composition examples. And that's all. I want to say that you're able to do probably 9, 12, and 13. But it seems like a lot of